Okay, so good morning. So this is going to be a final stretch. So only one morning of lectures, and then we will finish. I will finish by lunch, and then after lunch you will have 1 hour for preparations, and then will be the hour of truth after the preparation. So you will have an opportunity to give your presentations in front of venture capitalists who will decide then, as I understood, one winner, I mean, who may be even funded later on. But before going to that, I will tell you about prototyping. So how to prototype your products. And actually, the whole course by me has been geared towards prototyping, but there is just one very important link missing that I'm going to address today, and that is behavior modeling. And behavior is about algorithms, about procedures, about what the different components of your system are really going to do. Before we start, just yesterday's talk by Google reminded me one kind of anecdotal story. So do you know why one of the prime ministers of Australia resigned? I don't remember the name. We can dig it out, but do you know what was at least contributed to the reason why he resigned?
Picture on internet.
Yes, yes. Exactly, and what was the picture about?
I don't know, I'm just guessing.
Yeah, it's true. It's true. And you know what the picture was about. The picture was a mind map.
Mind map?
Mind map, yes. You know, the guy from Google talked about mind maps, and I mean, I'm not, well, against mind maps as such, but this irritated readers. And why? They didn't like the mind map. So why? Just guess.
Some bad words were there.
Not really. It was about a good cause. I think it was about a reform, some reform that he proposed. He was just trying to explain it in a very kind of figurative way.
People don't like politicians who say the truth.
Yes, that's part of the reason I think maybe people don't like the politicians to say the truth, yes, but, well, it was more like a psychological kind of reason.
They try to associate the picture with a human.
Yes, yeah, well, yeah, it's getting close, it's kind of warm, yeah. You know, the cold warm, yeah. Well, the picture was far too complicated. I mean, it was actually a flat picture rather than hierarchical and structured. Well, it was structured, but I mean, it was structured in such a way that actually no one understood what was represented, and this irritated people. And this is why I'm trying to promote here hierarchical way of thinking, hierarchical models. I mean, start with the purpose and divide it into sub-goals and sub-goals into sub-goals and so on. But this is a true story. At least, well, it's a kind of, maybe it has become a legend to some extent, but still, it's very important how you present your ideas. And this bear in mind also tonight when you're going to do your pitch talk. So it's very important how you present. And I'm quite sure this, for example, the goal models will work well because they are hierarchically structured. They correspond to how people think. So, as I said, we're going to agent behavior modeling today, and I'm going to intertwine it with descriptions of two case studies. So one is a case study of flirting. Can you imagine? I mean, using information technologies, a specialized device, software for flirting. Yep. And another one is about intruder detection in smart home. That is very much related to what you guys are doing here. So let's go on. So the slides for today's lecture are available online. At this location, and actually all the slides will be available online in the overall homepage for the course. So that will happen pretty soon. I think that will happen today. Okay, so about yesterday. So it's always good to wrap up what did we learn yesterday. So we learned about the knowledge by agents or software entities in your system, also by humans. So we learned that we need to represent both the private knowledge by these agents, both human and software agents, as well as shared knowledge, common knowledge between these. So that was yesterday. It was pretty simple because I didn't talk a lot yesterday. So yesterday we were here. Today we're going to be here. So again, this viewpoint framework that helps us to structure our ideas. So all the models they are accommodated into this viewpoint framework so that one would have a better overview of all the models and different aspects they address. And the aspects they address are interaction, information and behavior, and then it all happens at 3 layers of abstraction: analysis of the problem domain, design of your system, and prototyping of your system. And you cannot do prototyping without behavior modeling. So that's why today I'm going to complete the picture. So we will talk about agent behavior models, and later on about prototyping as well, after a break then also in the morning. Okay, what is a behavior model? Very simple. Well, it addresses what an individual agent of a specific type does. So very simple. When you have a system, or when you have a kind of a plan for your system, ideas for your system, then you should address what an individual component in that system does. And well, as you remember, maybe a small fresh up would do good here. So we mapped goals for the system as a whole. Then we decided roles that are required for achieving the goals. We decided the relationships between these roles. After that, we mapped roles to agent types. Then we decided acquaintances between these agent types, representing who interacts with whom, representing interaction pathways. And after that, we modeled knowledge by these agents, both shared and private knowledge. And now we are about to model the behaviors of those agents in order to have a complete picture. So I missed a domain model because a domain model precedes a knowledge model. So domain model belongs to analysis, and then a knowledge model belongs to design, and one is derived from the other. Knowledge model is derived from the domain model. So let's go back for a short minute to the abstract agent architecture that I already explained on Monday. So here, we have an agent has a knowledge base. And this is about agents' private knowledge. The private knowledge is stored here, but it is also about shared knowledge. Also, the shared knowledge may be stored here. So the idea is that the shared knowledge is stored in the knowledge bases of different agents, or a shared knowledge may be stored somewhere else. There may be some database or knowledge base outside. That kind of shared database that agents access, and then they retrieve their shared knowledge from that database. We had sensors, and via sensors, agents perceive what is going on, and sensors also include perceiving messages or receiving messages from other agents. We had actuators, and actuators, they affect the external world. They do it either by sending a message or by starting some machine, for example, in a physical way. And in the middle is controller that keeps it all together. And the controller then enables a reactive behavior when the sensors feed information directly into a controller, and controller decides to react by invoking some actuators. Or there can be also a proactive behavior that originates in the knowledge base, and then knowledge base sends a message to the internal message to the controller, and controller initiates some actions through actuators. Or there can be a combined behavior where a sensor senses something, one of the sensors senses something, can be a message received by the agent, then it goes via knowledge base, some condition is checked, and goes to the controller, and if the controller is true, then the controller decides to invoke some actuator. And this is the execution loop of an abstract agent. While the agent is unfulfilled, whatever it means, while the Tamagotchi is alive, for example, then sense the environment, update the knowledge base, reason, choose actions, and act, and do it again. For example, for a particular type of agent architecture, BDI agent architecture, which is a kind of derivation of this generic agent architecture, we have, instead of this, while the agent is unfulfilled, we have while the agent has unfulfilled goals, because BDI agents are represented in terms of goals. And in such a case, while the agent has unfulfilled or unachieved goals, then do this stuff. So that is the difference. Of course, that part is also more complicated for BDI, but we're not going into that. Now, some concepts that are important for behavior modeling: activity, action, and rule. So what is activity? This actually goes to activity theory and goes to social sciences, but I think it's very important with your product developments, because these days no product can be developed within just one discipline. You always need a multidisciplinary approach, and that's why it's good to know about social sciences, about psychology, about different areas in addition to just business and computer science. So these notions originate in activity theory by Vygotsky and others from his school of thought. So an activity is what an individual agent of a particular type does in its role to achieve the goals set for the socio-technical system. You see, again, we are referring to the goals set for the socio-technical system, but of course, these goals, when elaborated, they also refer to individual agents. So we start with the goals for the socio-technical system, elaborate them, and at the lowest level, some of the goals refer to also individual agents. This is one way to approach design. So an activity is also an agent's engagement situated in a specific social context that takes time, effort, and application of knowledge. And there are some examples of activities performed by people, but why not by software agents? Why not by robots? Like writing, resting, running, worshipping, waiting, singing, cleaning, and so on. And each activity belongs to some activity type. There are two kinds of activities, just like about knowledge. There is two kinds of knowledge, private knowledge, shared knowledge. The same is true for activities. We have private activities. Private activities performed solely by an agent playing a particular role, like walking. So I'm doing walking, or like for example, washing. I mean, I'm doing it by myself, for example. But a collective activity can be defined as an activity that involves several agents, like playing a tennis. Yes?
Can you go back to the previous?
Yes.
These are good examples, actually, of behaviors. Sleeping, eating, grooming are also behaviors. What is the difference between activity and behavior?
Well, activity is one process, but then there can be different activities, and they are governed by rules. I mean, in the sense that the question is, when does one or other activity start or end, under what conditions? Is because these are like the processes, like sleeping, eating, and so on. But then we need some rules to actually determine when they start, when they end. Yes, how they are related to each other also. And can they go on in parallel, for example, or maybe they are optional. So this is the.
But what is the difference with activity and behavior in these terms? Activity is behavior, or it
well,
is not?
I would say behavior consists of activities. Yeah, behavior is more complicated. Yes, yeah, it's more complicated. Yeah, behavior is more complicated, and we will see it soon by examples. Yep. Any other questions? Okay, what is action? What do you think? I was talking about activities. Now, what is action? Another term.
Putting the activities into practice.
Yeah, excuse me?
Like putting the activities into practice.
Yes, yeah, this is
The result of activity.
well, close, warm, but not quite there. I mean, they are not the same thing. I mean, now within this framework, they are.
Activity is like a process. Action is granular.
Yes, exactly. Yes, if I would have a prize, I would give you a prize now. Unfortunately, I have none. So yes, I mean, activities consist of actions. Action is an atomic part of activity. Yes, an atomic activity. Yes, exactly. Actions belong to action types, just like activities belong to activity types. And now there are 3 types of actions, and they are all considered as atomic, as happening instantaneously. Even though when we actually go deep, when we start analyzing, I mean, there is no such a thing as instantaneous action. But we need, for our modeling, conceptualizing purpose, I mean, we need the notion of instantaneous actions. Otherwise, we would just go crazy. I mean, if we start analyzing how much time does a specific action, like hitting someone, for example, how much time does it really take? Or blinking an eye, how much time does it take? I know it has been calculated, we know, but it's, I mean, it is pointless to analyze it. So we have communicative actions like sending a message. So how much time does it take to send a message? Well, it takes some time, of course, but it's not important for this kind of product design, for this kind of modeling. Physical action like starting a machine, again, takes some time, but it's not important for conceptualizing. Epistemic action or knowledge change in action, again, takes some time. The storing the image of a potential intruder, for example, in the intruder detection case study, it takes some time for sure, but it is not important. So we regard all of these actions of different kinds, so communicative actions, physical actions, epistemic actions, as instantaneous, happening instantaneously, taking no time, just for our modeling purpose. Okay, now we're coming to an interesting thing, and this is related to what you actually were asking before. And this is about how all activities and actions come together. And for that we need some other construct, and the construct we use here is rule. Very simple. I mean, rules that govern when activities are started, when activities are ended, how they consist of actions. How activities are related to each other, how actions are related to each other, all this is governed by rules. So under definition, a rule is a construct that models when an activity is created and for how long it stays active, as well as what actions are performed in its course. So just, I mean, how to put it all together, activities, actions, and the overall, and the results in the overall behavior of an agent. And now we're coming to an interesting case study I mentioned. There is an example, and this is from the case study of flirting. So I will explain this flirting stuff. It's a great product idea, actually. It's a very, very perfect product idea. Maybe some of you would like to develop it. Well, you know, it was actually researched scientifically. Well, it was modeled, it was designed, but for some reason or another, it was never implemented. But actually, what it means is that well, there is, I mean, two people usually of different genders, man and woman. They would like to engage in some flirting activity. So, and now, could this be mediated by technology? Well, let's imagine we have some device. I have some device, and the other person has some device, and it is in my pocket. And now, I mean, okay, I would like to flirt with someone, and then what I do, I mean, well, I'm on a meeting, for example, so I cannot text, I cannot use Skype or anything else, but I would like to engage in some flirting activity because the meeting is so boring. So, I mean, how do I do it with this kind of technology? Well, I just go to that device in my pocket, and then I turn the device in a specific direction. and this is the device perceives it and sends a message to the similar device of my partner, and the partner feels that that the device in the partner's pocket that moves also in some direction, and then the partner can actually go to her pocket and move her device, and then we engage in some unverbal flirting activities. So this is unverbal communication between us that both can enjoy. So definitely people can have fun through this kind of unverbal communication. So that was the case study. But unfortunately, it was never turned into a product. But I think it's a very clever product idea, actually. So why not? I mean, to do something like this. At least it has the feature of originality. Definitely, it's an original product idea. Sorry, I went too far. And the example of a rule about related to this case study is that if an incoming touch has been registered. So this is now about my partner's device. If that device has registered an incoming touch, a touch is this kind of flirting action. So if that device has registered that flirting action, that touch, and the partner is available, that is a mental condition that is checked and in the partner's device, because the partner can set her device to the mode where the partner is not available. Just like on Skype, we can choose that I'm not available, I'm offline. So, but if the partner is available, now this is the checking of a condition. Remember what I told about event, condition, action rules. This is checking of a condition. The flirting activity started, which means that the partner's device will turn in some direction, and that will indicate the partner that someone is willing to flirt with her. So this was example here is related to that case study. And the last item here just says that rules are always related to agent types. Rules are related to specific agents whose behaviors they govern. So it's about specific agents, and the rules determine what activities when will be started and what atomic actions and will be started. So any questions about this? Okay, and this is just to be complete. How we did it, or how my colleagues in Australia did it. Well, they started with goal models, naturally, and then they had many other kinds of models. I'm not going to show these other models, but just the goal models. Well, this is the goal model for flirting. Then we have the highest level goal, flirt. Then we have two roles, partner 1 and partner 2, that are played by humans. Then we have two quality goals, risky and playful. Has to be risky to some extent, especially when you engage in flirting activity with someone you don't know really, then it's risky. And playful also, and we could add here have fun as well. Then there are sub-goals, initiate flirt, respond to flirt. And then there are two roles now, touch giver and touch acceptor. And the touch giver is played by a software agent, who actually gives the touch based on the movement of the device in my pocket. So this is touch giver, and touch acceptor is played by a software agent in my partner's device, who actually accepts the touch based on the movement that her device does. And of course, in the middle is the message that goes from my device to her device. So and both devices have both agents. So my device has, the software part of my device has touch giver and touch acceptor. Agents playing the touch giver and touch acceptor roles, because here we're talking about roles. And the same is true for my partner's device. The software part of my partner's device has also agents playing both touch giver and touch acceptor roles. And then there is a touch perceiver role, and a touch perceiver role is related to the goals translate movement into giving touch. And now this is about my device. The movement, I move it in some direction, and then this is translated into giving touch and sending the touch to my partner. And here is translate movement into responding touch. meaning that that the movement then of my partner's device is this is translated into the responding touch. And then this software agent playing the role touch perceiver is the agent who is responsible for achieving these two goals. And then there is also one more role, device manager, and this is again played by a software agent or software component. Well, they do not, strictly speaking, they do not, these software components playing these roles, touch giver, touch acceptor, touch perceiver, and device manager, they do not have to be agents in the strict sense. They can just be software components, especially maybe those that are closer to hardware, like touch perceiver, I think. This can be some software component that is able to translate movement into touches. So why not? Yeah. But what is important is that conceptually, I mean, we need such roles in order to understand really what is going on, in order to understand the product idea from the very first sketch of the idea. And then there are also quality goals, accurate, related to both goals, sub-goals, translate movement into giving touch and translate movement into responding touch. Okay, let's go to some more complicated stuff now. Some more examples about behavior modeling. So that was just an example of rule, but this actually provided me with a good opportunity to actually introduce this case study, which is a kind of interesting, I think. Now about behavior modeling for Tamagotchis. Again, we are back to our digital pets, Tamagotchis, and the issue is, I mean, how do we model behaviors of those Tamagotchis? And this can be done by a diagram like this, which looks so awfully complicated, I know, but actually, I mean, it is not too bad. I'll explain. So you know some parts of it. This part you know, and I've also included this interaction diagram because I would like to point out some parallels. Okay, here, I mean, your digital pet is unhappy, so informs her owner, I am not happy. This is a proactive behavior, and this is initiated by the mental state of Tamagotchi. Tamagotchi is unhappy, and this is the rule that governs it. So the meaning of the rule is that if a Tamagotchi is unhappy, then the message I am not happy is sent to the owner. Here, this is the physical action by the owner through this graphical user interface using these three knobs here. And here the owner asks her digital pet to visit its friend. And here this rule starts an activity. This is now an activity. Connect with another Tamagotchi. Well, it consists of actions for sure, but they are not represented here. One advantage of these kinds of models is that we do not need to represent everything right away, but we can leave out some details and then we can actually elaborate these details later on. So here, connect with another Tamagotchi, sort of technical operation. And now there is a rule R3 that checks if the connection is operational or if there exists a connected friend. And now it is the same thing that we represented here, connection operational. Remember, these protocols, they were interaction models that, in addition to interactions between agents, represented some behavioral elements of agents. And this is exactly the behavioral element that is represented. Connection operational, and here it is represented using a bit different phrasing. There exists a connected friend. The same thing. So, and this here refers to the behavior of a Tamagotchi. Now, if there exists a connected friend, then this activity, visit the other Tamagotchi, will start. And that activity consists of sub-activities, and each of them is started by an appropriate rule. Rule R4 starts request visit sub-activity. The request visit sub-activity includes a communicative action of sending a message to another agent with a request, could I come to your place? Then rule R5 is receives this confirmation, please come. And the rule then, upon receiving this confirmation, this is called a trigger. I mean, each rule is triggered by some event. Like this rule is triggered by the confirmation by another Tamagotchi, please come. Or for example, that rule is triggered by the mental state of the Tamagotchi. Tamagotchi is unhappy. Okay, here is the trigger. Please come message from another Tamagotchi. This starts yet another activity, exchange greetings. Exchange greetings is here represented just partially, just one way. A good day, so no other message is not represented. In order to represent other messages, we should elaborate this exchange greetings, which is not done here for the sake of simplicity. And after greetings have been exchanged, we enter this given present and play loop. And what happens here is that, again, we check the mental state of the Tamagotchi. If Tamagotchi has enough presence, then it will give a present. Remember here, enough presence. This refers to the mental state of Tamagotchi, even though it is an interaction model, but we refer to some behavioral elements. And this is done here. If Tamagotchi has enough presence, then it will give a present to other Tamagotchi. So if it has enough presence, then according to rule R2, it gives a present, and if not, then it will actually surpass this stage, or this activity of giving a present will go straight here and will engage in playing with another Tamagotchi. So this is a condition here. If Tamagotchi has enough presence, then it will give a present, please accept my present. If not, it will go here, will play with another Tamagotchi. Again, it is partially represented here through just one message. And then after this activity, give a present and play has been completed, we come to rule R7, and rule R7 checks if the Tamagotchi is still unhappy. And if it is still unhappy, then, well, it needs more entertainment, and this entertainment entails in giving a present and play. So we go back here, and again the same thing is repeated until the Tamagotchi is happy enough. So and here for this purpose we check the mental state of a Tamagotchi. So that's it. So just one way to represent behavior. There can be different ways. It's not the only way. It may not be the best way, but it is one way how to do it. It is, I would say, well, now it depends how we define a behavior. I would say it is one behavior because it is related to this, actually, to visiting the other Tamagotchi. So it is one behavior, that visiting behavior that is represented here, that consists of different activities, actions, rules. Yes, yeah, it is one.
Presenting the present is only the part of the visit.
Yes.
The present
yes.
Other way, like
yeah, exactly. Yeah, it is just one part is this giving a present, yes, and playing is another part, for example.
If I decide to have more function for Tamagotchi, for example, exchanging presence over email or post,
yes,
then I need to make a copy of this behavior for the to this part.
You need to elaborate it then and make a different behavior then. Yes, exactly. Yes, make a difference. Maybe extend this behavior somehow. Yeah. Yep. This can be done as well. You can extend activities pretty much like object types. Yep. Okay. Any other questions? This is getting technical, I know now, but but actually I promised to Alar, our boss, that I'm going to get technical at least on the final days. So because I'd like to actually give you some ideas about how you could prototype your products, even if they are not agent-based products necessarily, but you can prototype easily by using agent-based approaches, software agents. This is another format for agent behavior model. It is an agent behavior model for shopbot. Remember this, in this grocery shopping example, we have those wonderful shopbots that help us to make decisions about grocery shopping, where to go, what to buy, which stores to visit. So, and this is represented as a table. Here we have, first of all, we represent the role, assistant, agent type is shopbot. And then we represent now these different rows represent different activities. But each activity has a trigger. Like here, the trigger is the shopping list has been created. So this is the trigger that creates or that starts this activity. Then we have a condition, for meaning that this activity is repeated the number of times determined by the condition. In this case, it is repeated for each product on the shopping list. Okay, the shopping list has been created. Now we do for each product on the shopping list the following. We retrieve the price and quality of product evaluations of this product in different nearby stores. So it's a loop, actually, like in programming. It's a loop we do for this product. Here are shown other roles, agent types involved. Coordinator agent is involved here for sure, because we ask this price and quality of product evaluations of the product in different stores from the coordinator agent. Well, because we decided here in this system to have this kind of architecture where we have shopbot agents representing customers and a coordinator agent who keeps track of the prices and quality of service evaluations for different stores. Here we show the conceptual objects that are involved, like shopping list, product information, store information, customer location. So these conceptual objects are involved in performing this activity. And here, goals. So it's good to remind ourselves about goals and quality goals that are relevant for this activity. They are like find potential stores, quality goal is close, exchange price and quality information, with the quality goal secure, minimal participation, and anonymous. So here is where it all comes together. So we actually we represent behaviors of agents in terms of activities, but we also remind ourselves about goals from the analysis phase, so that we won't miss anything, because the goals represent requirements for the system. And here, where we already actually design the system, where we're close to implementing the system, we should remind ourselves about the requirements, so that we won't do anything wrong, so that everything we do would actually conform to what customer stakeholders they want of this product, how they want to see that product. And the same here, the price and quality of product evaluations have been retrieved. This is the triggering condition. The condition is that if the price and quality of product evaluations have been retrieved from the coordinator agent, then for each potential store, because it hasn't been decided yet, we perform the activity of deciding a shopping basket for that store. And the shopping basket for that store contains the information, about products to be bought from a particular store. So we create several shopping baskets, one for each store, and so a shopping basket for a particular store contains the descriptions of products to be bought from that store. Okay, then here is a human agent involved, conceptual objects involved, and relevant goals. Then after shopping baskets have been decided, which is the triggering condition, then for the best combination of stores, because here we did it for many stores. Not just those where we are going to go, but also all the rest. Many potential stores that sell the products of the kind we are interested in. Here, we do it for the best combination of stores. Because we have, by now, we have made a decision, what stores to visit. So we decide the route to those stores. Again, human agent is involved, conceptual objects involved, and relevant goals and quality goals. The goal decide the route, quality goal optimal. After the route has been decided, then we propose, the shopbot proposes the store's shopping baskets and route. The same thing here, conceptual objects involved and relevant goals and quality goals. And this is then about shopping. Another part is about giving feedback about particular stores, about quality of service, and giving feedback by customers, And here the condition is product information for the given product has been registered. What I mean here is that the shopper may have actually a device enabling the shopper to read barcode. So, and this device is used for registering the price. Of course, the price is not always included in barcode, but let's assume it is. So, and now this this triggering condition here refers to the situation where this information about a particular product, price, but also ingredients. Ingredients are important because some customers may have preferences for healthy products, so it is not just about price, but also about different criteria. Health is a very important issue here, and also quality of the product and quality of service in a particular store. Then the activities post price and quality of product information for the knowledge of other customers. And this is done by coordinator agent here. Of course, what human has to do, human has to actually to register the price, but the rest is up to the coordinator agent, who then actually publishes that knowledge for other customers. Because a coordinator agent is a centralized agent, so it is sitting somewhere and it interacts with the different shopbot agents. The same thing here, I mean the same triggering condition, product information for the given product has been registered, and now the activities complement the typical shopping list, meaning that the shopbot just helps the shopper to complement the shopper's typical shopping list. Because this products chosen by a shopper may include some new products that were not there before, and now it's up to that shopbot agent to analyze if this is the first time when the customer, I mean the master principle of the shopbot agent is going to buy these products, or is it already repeated. If it's repeated, then it may make sense to complement the typical shopping list with these products. So that's it for just another way how to represent the behavior of an agent. Yep.
Why in this shopbot prototype you didn't mention any words about actually price recognition, because nowadays we have very good OCR systems and algorithms. So you may scan barcode with even handy writing, right?
Yes,
it's all numbers.
Yes.
You need to recognize the text, but numbers can be easily parsed.
Okay.
From the price.
Okay, now I know. That's the point is, what I said is that this barcode usually doesn't include the price, but the price is somewhere.
But price somewhere.
Yes, somewhere, yeah. So we can read it with this OCR, for example, technology.
You can actually take a picture and recognize that this part is a barcode, and went to barcode recognition. This part is a number, it's a price. So basically it's two variables only for the
Yes. Oh, this is a good idea, actually. Oh, this relates to one other idea here. That was about taking pictures. So maybe you can just take a picture of the price, recognize that price, digitalize that price. Yes, and this is about your, actually, I think your idea as well. So maybe we should combine it with this smart grocery shopping. So yeah, we may not need actually that barcode after all. So we may actually be able to digitalize the price without the help of the barcode. Or I think, exactly. Part of your idea was that, I mean, we sort of take photos of different things of interest. Why not of different products with prices, and then this information is processed. And of course, the issue here is how, how efficiently can we process this, the price number, if it's just a number. But usually they are printed anyway, so it might be easy. I mean, if it's handwritten, it can be tricky, but if it's printed, then yes. Oh, okay, now we see how this
capture in internet is much more complicated and still broken. I mean, so many algorithms broke the capture, but it's not a capture. It's
exactly.
You will have a very high level of recognition. Of course, some percentage will be of false.
Yes.
I think
about another, if barcodes can be read by a reader, surely there's a program that can be put up on the website and actually read as well.
Yes, they can. I mean, then it's very well organized in the US, I know from my own experience. I mean, there are very, very systematic, very good part codes. They tell about everything, about ingredients, about the origin of product and so on, but usually nothing about price.
Full information.
Yes, but full information is available. I actually miss it here. When I returned from the US last year, I really feel I miss it because it's so well done there, but no price. How many calories? Yeah, all this stuff. All this health stuff is definitely there, and all this chemical substances added and so on. Yeah. But this was a good idea, and then now it relates to your idea. You see, I mean, what is innovation really? Well, innovation is nothing but a combination of different ideas. I mean, it's not. I mean, it's very rare when someone actually comes to a totally new idea, like the Nobel Prize winner who gave a presentation here. I mean, okay, he's the guy. Yes, he's genius. But most of us are like ordinary people. So we really, I mean, come to a completely new ideas. We are not Einsteins, but we can actually combine different ideas. And this is an example. I mean, how by actually getting some input from you and then thinking about your product idea. I mean, we could do something. So yeah, think about it. Yeah, very good.
Matching, as example, it could be like matching profile data with related products.
Yes.
If I have a history that I'm ordering pieces, then it's related to like this product.
Yes. And what agent or component is going to do it?
It's a database system engine.
Okay, like database engine or some, because it is related to the database. Yeah. Okay, good. Thank you. Yeah. Any other ideas?
We took the simple example of sensor agent. Let me say it's only one parameter we sense, temperature. Sensor agent should have two kind of behaviors. One is reactive. It will answer with the value of temperature by request from anyone.
Yes.
And the other is proactive. So it constantly monitors the value of temperature, and when temperature changes, it informs the system that temperature has been changed.
Yes. Okay. Yes. So one is then reactive. It's about a particular value.
Yes.
Is it?
If some part of the system need to know what is the value of temperature right now, it responds that temperature is like X.
Okay. Just ask it.
Temperature is changing by itself. We can't control, or we control it.
Yes.
But it changes. So if the change happens and it monitors that the value has been changed, then it publishes the messages because some of the parties may be interested to react on these changes.
Yes. So one is the reactive behavior. This is kind of simple, just answering a query, and the proactive one is more complicated. It's about following the trends and then informing, if needed, some other components.
Or everyone.
Or everyone. Through the bus. Yes. Okay, good.
I think this should be like more like subscriber publisher. So the one who interested in these changes will subscribe to this service, and they will receive messages as the temperature has been.
Exactly. Oh, very good example. Even two examples. Thank you. Any other ideas about behaviors in your systems, in your products? Okay. Then we can now take a break of 10 minutes, and after a break I'm going to talk about prototyping. So it's becoming a bit more technical, but I will include two videos. So two examples, how a prototyping has been done. They're both from Australia, but both are very exciting. So please stay with me, and it will be quite an entertaining second session of this morning. So thank you.